Yes, I guess we can start. Good day. I am Dursun Murat Sekban from Karadeniz Technical University. On behalf of the organization committee, I would like to welcome all participants. Our special session A, which will last for 1 hour, will be about innovative shipbuilding in Turkey. Within scope of the session, firstly, Ms. Mehtap Karahallı Özdemir from Turkish Shipbuilder Association GİSPİR will make her presentation on Turkish shipbuilding overview. Afterwards, Mr. Burak Mursaloğlu from Cemre Shipyard will make a presentation on innovative new shipbuilding. And finally, Stephen Carter from the Welding Institute, United Kingdom, will make a presentation on the introduction of the Resurgam project, robotic survey, repair and agile manufacturing, friction stir welding technology for the shipbuilding industry. At the end of the session, after all the presentations are over, if you have any question about the presentations, we can take them. Now, I would like to leave the floor to Mrs. Mehtap Karahallı Özdemir to make her presentation.
Thank you very much. First of all, I would like to thank the Congress organization for this special session about innovative shipbuilding in Turkey. I try to open my presentation here. I think you can see now.
Yeah, we can see.
Okay, thank you. I would like to give brief information about Turkish shipbuilding industry. Our history of Turkish shipbuilding industry is based on 600 years ago. This is Imperial Arsenal Shipyard. And our association was founded in 1971. So we can say that we are one of the oldest non-governmental organizations in Turkey. Now we have almost 100 members. And when we look at our mission and activities, we can say that the improving of Turkish shipbuilding industry, helping Turkish shipyards position themselves in the global market, establishing a bridge between shipyards and relevant authorities, associations, and organizations, and also representing our shipbuilding industry in international and national audience. When we look at our figures, currently we have 84 active shipyards in Turkey. And you can see our member regions on the map of Turkey. We can say that we have a unique advantage for shipbuilding industry. We are very close to Europe, and also we have adequate climate conditions for shipbuilding industry. Currently, GİSPİR is a member of Sea Europe, Active Shipbuilding Experts Federation, Waterborne Technology Platform, and ELS platforms. We are a council member of SF, Active Shipbuilding Experts Federation also. And we try to conduct so many international activities. We try to involve most of them. You can see some examples for exhibitions, some sponsorships, and also activities about some conferences. We have currently 2 European Union projects. One of them is Safe Shipyards with Technology-Based Trainings. We try to develop e-learning modules and also virtual reality modules for shipyard employees. At the end, we try to disseminate all these training modules to our member shipyards and reach maybe 45,000 employees in Turkey. And maybe afterwards, we can take all of these developed training materials. We can also provide some support for Sea Europe other members. And other project is Horizon 2020 Resurgam project. Stefan will give some brief information, I think, about friction steel technology. This project is approximately 13 partners in the project. You can see the names of our partners. And Gispir is the only Turkish partner in the project. So at the end, we try to develop robotic survey, repair, and agile manufacture systems by using friction steel welding for steel manufacturing. We can say that why Turkish shipyards are important for maritime industry. Our members are reliable, and we have production quality and on-time delivery. In Turkey, there are so many authorized equipment suppliers, classification societies. We have good communication between clients and shipyards and high-quality supply chain. When we look at shipbuilding capabilities, our new building capacity is approximately 4.65 million deadweight ton by 2020. And for repair and maintenance capacity, we have 25 million deadweight ton. We have really good infrastructures for repair and maintenance and also for new builds. We have 11 dry docks and 33 floating docks in Turkey. This is one of the biggest floating docks in Turkey and also in Europe. It's an example. What we can build, we can say that we can build very innovative and environmental friendly, sophisticated ships. I try to give some examples. Ferries, passenger vessels, some of them are LNG hybrids or battery powered ferries. Energy ships, it's a unique kind of ship which can provide energy supply from ship to shore. Maybe you can see some operating ones generally in African countries. I think there are 13 ships now operating in African countries. And tugboats, some of our members are really specialized on tugboats. The world's first battery-powered full electric harbor tugboat was built by one of our members. The other member built the world's remotely operated commercial vessel and LNG-fueled escort tug, and also the world's first advanced variable hybrid tug. We have really good experience in tankers also. You may see some example for product tankers. And we are experienced in platform supply vessels. You can see some examples here. And for mega yachts, we are the third in the world for yacht building. We have really good and luxury mega yachts examples. And fishing vessels. Now you can see different kind of fishing vessels. The world's largest live fish carrier, the world's largest longer and Danish seiner fishing vessels are some examples. In the past, between 2002 and 2012, we were the first in the world about small tonnage chemical tankers. We can build, but it's according to the market status, you know. The chemical tankers uprise is not common nowadays. And bulk carriers and containers, these are conventional ships. And this is an interesting slide about autonomous vessel. One of our member shipyards, the world's first laser-guided missile system integrated armed unmanned surface vehicle. And the other shipyard already built the world's remotely operated commercial vessel. And also one of our member shipyard is now building an icebreaker. And this is the first research vessel for seismic research in Turkey, which is built by one of our members also. As I mentioned before, we are third in mega yacht building, and you can see figures according to the years. As I mentioned before also, we have really good infrastructures. So we are really experienced about repair works and also retrofits. This is one of the interesting example, which is very quick repair within 25 days. As I mentioned before, our Turkish shipyards clients are generally from Europe. So we have focused on EU requirements and IMO requirements. We are really interested in European Green Deal objectives, and we try to comply with these objectives as an industry. And also we are following up IMO requirements. So I would like to give examples about innovative and environmental friendly projects from our industry. This is the world's first LNG powered escort tug. So there is limited amount of carbon dioxide emission. This is another project, the world's first battery powered electric harbor tugboat. So this tugboat have zero emission, and now it operates in Tuzla shipyard region. So the main aim at future is to decarbonize Tuzla region in a few years, I think. Now we have only one zero emission electric tugboat, and we will have maybe 4 or 5 in a few years later. This is another project, the world's largest all-electric ferry. And this is another project, coastal passenger ferry, LNG and hybrid propulsion system. And for about innovation in shipbuilding and repair industry, it is a unique example from one of our members for lengthening of ship. The system was partly funded by Turkish TÜBİTAK, Turkish Research Institute. And also I would like to say some words about green upgrades, retrofits. Our member shipyards have already finalized more than 350 ballast water treatment retrofits and more than 150 scrubber retrofits in our industries. So we can say that we are really great experienced about retrofits. And when we look at Navy and Coast Guard projects, we can obviously say that building naval ships increase our experience for workers and also for engineers about building complex ship types. And I try to show some examples of these projects. This is Anadolu ship, and this will be the biggest ship in our naval fleet. Another example, search and rescue ships, Coast Guard boats and ultra-fast boats, submarine rescue mothership and rescue and towing ship, rescue and towing ship by another member, new type of petrol boats, landing craft tanks, landing ship tank, logistic support ship project, and corvette projects, which is a part of Milgem project, and emergency rescue and diving boat. Another project from one of our shipyards, naval fleet replenishment ship. I would like to say some words about COVID-19 and the pandemic in Turkish shipbuilding industry. At the beginning stage, we have main focus about making some measures about pandemic, and we prepared guidelines, and I would like to show the results. The main focus is keeping everyone safe. And as GISPIR, we prepared guidelines, which includes general requirements, working areas requirements, cafeterias, transport areas. We used WHO guidelines, ICS guidelines, national instructions, so many things about when we are preparing guidelines. And we disseminate the guidelines to our memberships, and they strictly use that measures. These are some examples from our guidelines and some measures. You can see some measures in our shipyards. Also, our government developed an application in order to verify that someone is risky or not. It is a unique system. It's has code application. So we always request our employees and also foreign visitors to show they are not risky by using this app. And at the end, we can say that we have managed to control the pandemic situation in shipyards and to keep sustainable our works. Thank you very much for the opportunity.
I would like to thank Ms. Mehtap Karallı Özdemir for her presentation. Now I would like to give my word Burak Mursaloğlu from Cemre Shipyard to make his presentation about innovative shipbuilding.
Thank you very much. My camera has a problem. I am sorry for that, but I will share my screen first of all. Can you see the screen?
No.
It says you are trying to share your screen, but we couldn't see anything yet. It's okay now.
It's okay. We can see now. I think there is a problem in Burak Mursaloğlu.
I think the connection has lost.
Yeah, probably.
Maybe Stefan
Okay.
can make his presentation before Burak and we can solve the problem.
Okay.
Yes, I'm willing to try that.
Stefan, are you ready? Because there's a connection problem with Burak Mursaloğlu.
Yes, I can give my presentation.
Okay.
Okay, thank you. Thank you.
I would like to thank Stephen Carter from the Welding Institute make his presentation.
So hopefully you can now see my slides.
Yes, we can see.
Okay, so what I'm going to talk about is the EU project Resurgam, which is about developing friction stir welding. And so to do that, I'll talk a little about where friction stir welding was invented and how it's been used already in aluminium, and how Project Resurgam is now transferring that technology into developing friction stir welding for steel.
Stefan, may I interrupt you? Because I think it doesn't fit on the screen very well, your presentation. I don't know why, but we couldn't see some words very well.
Yeah, your
On the
screen
left
appears
side, on
halfway.
the left side, there's a loss. Could you please change?
I'll just see if I can change it.
Yes, it's okay now.
Okay, okay now.
Okay. So initially, friction stir welding was invented 30 years ago by the Welding Institute, and it's a very simple process which doesn't actually melt the metal. In many ways, it's very similar to milling. So what we do, we have a rotating tool which we lower down onto the surface of the metal that we're about to join. The rotating tool generates heat through friction, and that softens the metal, and then it is actually stirred together. And the important thing is that we don't actually melt the metal at all. So we get a very strong bond. So this actually shows the process in use. So this is a video which shows two pieces of aluminium being joined. The aluminium is 50 millimeters thick, and we're welding it from the top and the bottom simultaneously. Because we're not getting any melting, we can weld in any position, including directly overhead. So we're seeing the two tools embed themselves into the aluminium. The aluminium internally is now very, very soft, and we can stir it together by moving the tools along through the aluminium. And as I mentioned, we can weld upside down because we've no liquid metal there. It's still solid, and so we can weld in any position. That also means that we can weld underwater as well, because the water does not get into the weld zone. As you see, we don't get any fumes, we don't get any sparks, we don't get any ultraviolet. We get a very nice smooth surface finish to the weld. In many applications, it's not necessary to do any post-weld dressing because the surface is good enough to put straight into service. And then at the end of the weld, we simply extract the tool. So realistically, it's very similar to milling, gives an extremely strong bond, it's completely mechanized, and gives very good results. It's been around for about 30 years and is widely used in a lot of industries. So this particular image shows the space shuttle fuel tank, which was fully friction stir welded. The benefits of the process is that it can allow you to make a very good single pass weld up to 75 millimeters thick in aluminium. It's mechanized, it's repeatable, so you always get the same quality of result. We don't need to do any specialized edge profiling or cleaning of the metal before we join it. We don't use a shielding gas or a filler wire for joining aluminium, so you've got cost savings involved. We get very, very little distortion or shrinkage. We're not melting anything. We're not putting a lot of heat there, so we don't get much distortion. We can weld in any position, vertically, overhead if necessary. We get very, very good weld properties. We don't use much energy because we're not melting anything, so we got a very energy efficient process. We get health and safety benefits too, because we've no fumes, we've no ultraviolet radiation, we've no electromagnetic radiation, so it's a very safe process. In terms of the materials that we can weld, the process was developed for aluminium, and it can do any type of aluminium, including some of the grades like 2000, 7000, and some of the 8000 grades that cannot be welded by arc welding. We can work with extrusions or castings. We can even weld metal matrix composites. After the process was first developed, we were then asked if we could weld magnesium, copper, zinc and lead, titanium, and nickel alloys, and we can weld those materials as well. So it's a very versatile process. And then most recently, we've been asked if we can weld steel. Just thinking about where it's already being used, friction stir has been used for about 20 years in aluminium ships. There are quite a lot of companies using it, including a Turkish company, and it's often used for modular construction of things like decks, bulkheads, helicopter landing pads. A lot of honeycomb type panels can be friction stir welded, as can cooler and chiller plates. So it's widely used already in aluminium in the marine industry. It's not just commercial ships, but a lot of military ships use it as well, because it gives incredibly strong, stiff, lightweight joints, which are very resistant to damage. We've got variations upon the technique, which can actually weld through closed sections. And so, for example, it's very simple to use a type of friction stir welding called bobbin welding to join two C-shaped channels to make long tubular structures. So, for example, things like fuel tanks, masts, heat exchangers, or chiller plates can be welded in that manner. We can weld different thicknesses of aluminium together by having a specially shaped tool, which then blends the joint line between the two plates and gives a nice smooth transition between the two parts. And in aluminium, we can also weld into corners and give a full penetrating joint. And under testing, we find that the failure tends to occur in the parent metal and not in the weld itself. So because of all this benefits that we bring to the process in aluminium, people started saying, could we actually friction stir weld steel? And in particular, could we do that for the shipping industry? And this question was first asked well over 10 years ago now. And we've been working on developing the process in a number of projects to try and develop friction stir welding tools for welding steel. The early problems that we encountered was that the tools wore out very, very quickly. They were quite expensive. They also had inconsistent performance. And so we needed to develop a much better tool. And it's taken quite some time to do that. But we've now been working with a company called Element 6, who are developing some new tools, and these are just coming onto the market, and these are suitable for welding steel. The problem with welding steel is that we're working at nearly 1000 degrees centigrade, so it's still solid, but it's very hot, and we need tools that can be very strong and withstand working in steel at those temperatures. We've now developed tools like that, and I'll show you a small video of some friction stir welding of steel. So what we're seeing here is the tool slowly embedding itself into the steel plate, and it's now traversing along the surface. And you'll notice that because we're working at much higher temperatures in steel, the tool is now glowing bright orange, indicating that the tool is hot, but the weld itself is still solid, and the weld itself is not glowing. It's still a nice, strong weld. As you can see, we get a very smooth, regular, consistent surface, and the plates that we're welding are not distorted. The tools themselves last quite a long time, and you'll see in a moment that even after welding many meters of steel, the tools themselves haven't worn. So this particular tool has welded over 40 meters of steel and is still in good condition. So it's a very simple process and is now possible in steel. In terms of the different grades of steel that can be welded, we're finding that we can weld almost any grade of steel because we're not melting anything. We're not changing the composition. And so even some grades of steel, which are considered very, very difficult to weld by conventional techniques, we can weld by friction stir. For example, we can weld a carbon steel to a stainless steel without problems, which is very difficult to do by other techniques, but friction stir can do that. In terms of the weld properties, those are very good. On the left-hand side of this slide, you'll see some tensile test pieces, and all of those have broken in the parent metal and not the weld. So the weld is actually stronger than the parent metal. In the center of the image, we see some Sharpie impact test pieces. None of those are fully broken, indicating that the weld was very tough and still had a lot of ductility. And then the graph on the right-hand side of the screen shows one of the Lloyd's Register acceptance tests for fatigue. And all the friction stir welding that we did was above that red line, which was the acceptance criteria that was set by Lloyd's for this particular example of work. And so it seems to be that friction stir in steel gives a stronger weld, a tougher weld, and a much more fatigue resistant weld than the competing processes. So we've been tasked under the EU project Resurgam to take this process further and develop the process for two particular applications. One of them is to use the fact that we can weld underwater using friction stir, and to develop a robotic system which can carry out repairs on marine structures without needing to dry dock them. So the repair can actually be done at sea by a robot. The second task is to make use of the ability of friction stir to make joints with very little distortion, so that yards that are developing modular construction techniques or are inserting plugs into ships to lengthen them can weld using friction stir. And because there's no distortion, everything will fit very well together when the final ship is assembled. So the project itself is split down into different work packages. The Welding Institute and Element 6 are developing the tools that do the welding, and the quality of those welds will be assessed by the Technical University of Delft in the Netherlands. And we're getting a lot of input from the shipbuilding associations, such as JISBEA, on telling us what grades of steel are needed, what thicknesses of steel, and the kind of applications that this will be applied to. So we are getting a lot of help from the member shipyards of the Turkish Shipbuilding Association. The second work package is being led by J4IC, who are developing all the digital infrastructure that's needed to send drawings of ships around, repair plans, modular construction plans, and also to develop the control software, which will control the friction stir welding systems and integrate all those together. The third technical work package is the development of an underwater robot that can actually crawl along a ship and actually weld a repair patch in place. And obviously, this does have potential other applications as well. It could easily be doing work on wind turbine towers at sea or any marine structure at sea underwater. And this project element is being led by a company called Fourth Engineering, who have a lot of experience in robotic systems for use at sea. The second strand of the project, developing the friction stir systems for use on land so that the shipyards can undertake modular construction, is being led by a company called Stirweld, who are developing a friction stir welding system that can actually be fitted to an existing CNC machine tool system. And they're already finding a partner in Turkey that will be able to help them do that and actually allow companies to adopt friction stir at relatively low cost. The fifth work package is again led by Fourth Engineering, and this is where all the systems will be brought together, integrated and demonstrated, and this will take place in about 2 years' time. And obviously, we're getting a lot of help in the project management and dissemination from the European Welding Federation and the shipbuilders associations such as JISBEA and Aklanaga. And we very much welcome input from member companies of JISBEA and the Turkish shipbuilders in general. We would love to know how you would like to apply this technology and how we can make it better for you. So that concludes my presentation about friction stir welding as a technology and the Resurgam project. And if you have any questions, I'll be very happy to answer them later on, or you can email either myself at TWI or the project coordinators, the European Welding Federation, and ask us as many questions as you like later on. So thank you once again for listening. Thank you very much.
I would like to thank Stephen Carter for his presentation. I think your presentation will be very useful for introducing the method to our industry. Meanwhile, I completed my PhD study on joining of steel using the shipbuilding with friction stir welding. In this welding method, as you said, the energy use and harmful emissions during the welding are very low because of the joining done quite under the melting temperature. On the other hand, the welding region of the friction stir welded shipbuilding steel show better mechanical properties than the such as gas metal arc welding or submerged arc welded steels. For all these advantages, I foresee this method will be used effectively in our sector in the near future. I thank you very much for your presentation again, Stephen Carter. Now, finally, I would like to give the word Burak Mursaloğlu from Cemre Shipyard to make his presentation about innovative new shipbuilding.
I think this time we managed to attend and continue. First of all, thank you inviting me. I am here to represent Turkish shipyards, and I would like to show some examples about how extraordinary projects we are working on and we are building and we are planning for future. Actually, there are some slides in this with the same with Mrs. Mehtap, but as technical questions, I can help you if we finish this presentation. Actually, as you can see, as a Turkish shipbuilding industry, we are trying to build very extraordinary projects in last 10 years. As you can see, two of them, one of them has already delivered and leave us. This is the first LNG and battery-driven purseiner trawler in the world. I think the same shipyard, my shipyard is building two more for this kind of vessels. And this is the below, the Havila Kırsruten is now building in neighbor shipyard Tersan. They are trying to deliver the first and three on them is under construction. These are very environmental projects and hopefully they will affect also Turkish shipbuilding industry very positively. And also this is the business is not usual for us nowadays because in 10 years after the period of tankers and bulk carriers, Turkish shipbuilding industry and engineering philosophy has completely changed, and we have changed our mentality to unique vessels, niche vessels, and we are really courageous in this regard to build one of its kinds in the market. As you can see, these power ships, remote operate commercial vessels, first LNG tugs, and first hybrid service operation vessels, Maltese Falcons. As you can see, these are completely different than each other as a perspective. As a shipbuilder, all of them has significant complications, but all of them has been delivered in very good cooperation, and it's like working nearly perfect in the market. And while we are discussing about the era of 10 years, this is a challenge for us. I think in Turkish shipbuilding industry also changed mentality in this regard. Also market changed the mentality. First, we started to find reducing fuel consumptions with some making some arrangements. And then we are trying to use alternative fuels, LNG, low sulfur marine gas oil. It's getting popular. But after that, the electric, it's come to our minds as a clean electrical energy. And we have combined in lots of projects as diesel electric, this fuel and clean electric energy together. And now it's day by day, it's growing battery applications, fuel cell applications. Of course, it's coming there. But also we are not, we are following the small items which we can save energy, like electrical winches, anti-roll tanks, exhaust economizers. There are several this kind of small items can contribute even less, but it is important for the futures and for energy saving. While doing that, actually, the Turkey has a significant advantage because we are middle of all building activities, and we have several good shipyards to build, especially some size complex vessels. And for this regard, we have a strengthened competence about below vessels like fishing vessels, any type of fishing vessels actually nowadays, offshore mostly wind segment, and I think we are the market leader for ferries. Also, I forgot to add here, especially the tugboats, definitely. And with this regard, the Turkish shipbuilding industry is, we are answering the demands of the customers with some advantages. And actually engineering, one of the good things, I have been in this business 10 years and I see what is changed as an engineering. Firstly, the customers are coming to Turkey just for price issues, but now actually even we are expensive in some other European countries, they are selecting us because our engineering facilities actually. And of course, when you have a good engineering team, and definitely the timely deliveries are coming afterwards, and also this is affecting the ship owners very much. And the flexibility, I think it's the most unique function of shipbuilding industry in Turkey. This flexibility, we are trying to find alternative solutions to owners, and we are trying to find energy saving or reducing the cost, or operational wise, we are trying to find alternatives to them, because some of the vessels we are really good track records and we are learning a lot about the vessels. And of course, I think I can say we are the best in price quality balance, if you think about that, in Europe, maybe in the world, in some segments. That's why this is our highlights actually for the, and we have a huge tradition as a shipyard capabilities, but actually now I saw more than 80 shipyards in Turkey, but they are not all of them ready for future, and we have to prepare ourselves for the future. We have to follow the technological improvements, and we have to learn to build multiple type shipbuilding capability. We should have a suitable infrastructure, and of course, this is the one of the important criteria for Turkish industry. We have to keep our engineering philosophy, our engineers, and we have to keep our or extend our know-how capability. And of course, we are doing mostly with European customers, as Mrs. Mehtap mentioned. We have to follow the quality and environmental standards. I think most of the good shipyards in Turkey has already standardized themselves about these certifications and the experience-wise or working philosophy. Also, one of the important thing in this regard, we have to, as I mentioned, we have to prepare ourselves for the future, and we have to, how can I say, increase our strategies for future. And for that, we have to improve our local sub-suppliers. For example, like cruise vessels, we have to increase our local sub-suppliers to increase the facilities. And then we have to give education to our people. Actually, the language as an English, it's getting better and better because it's a common understanding. But also we have to give this advantage to our workers as well. This is a good opportunity because in Turkish shipbuilding industry, 90% of the industry is for foreign people. That's very important. And of course, in this regard, the finance is everything. Now our government and banks are supporting us. and we are trying to find new alternatives, new financial supports, because at the end of the scenario, this is a business, and also we have to think about the business case as well as shipyards and also country. Actually, we have to believe that as a shipbuilder, and also our fellow friends thinking the same. In this market, there are lots of up and downs. In Turkey, we see a tanker and bulk carrier era, but now everything is changed. That's why we have to prepare ourselves as a market, also as a shipbuilder, for different kind of vessels. Actually, we can learn each one of them, and we can implement the learnings in different vessels as well. This is good to build different kind of vessels. And actually, we have to not underestimate the effects of technology. I would like to show information, one case study of Libas. As I mentioned, this is the first purse seiner in the world who is using LNG and battery together. As you can see, at the same size vessel, the carrying capacity, the fuel is 15% less, the NOx emissions is 81%, and CO2 emissions is 24%. That is a highly unique advantage. And this vessel is under operation now, and the numbers we have received actually better than this result, especially the fuel and CO2 emissions. And actually, also we have to follow some unique projects. I would like to give information about the Norwegian ferry fleet. I think in Turkey, we are very much in favor about this Norwegian ferry fleet replenishment program. I think more than 60% of the ferry development has been building in several shipyards in Turkey. And with these projects, we have learned a lot about battery configuration and also electric hybrid solutions. Also, these vessels has energy promises to their governments. That's why they are trying to recover all the energies from every possible system. This is also highly advantage that we are learning the systems as a shipbuilder and also engineers. And also nowadays we are trying to also contribute these projects. Even they are the market leader about these technologies. We are trying to find and contribute as an engineer how we can make much more eco-friendly vessels together. And as I mentioned, the technological improvements are based on clean earth effect. Everybody should remember that actually. And we have to prepare ourselves for the future. The alternative fuels like hydrogen and methanol. The first hydrogen ferry from Norwegian fleet has been delivered already, for example. There are some methanol projects in the market, and I think it's day by day increasing. Also for some subsystems like fuel cells, hydrogen cells, also is using in so many projects, but we need to study, maybe we need to produce as a country this kind of cell technologies. And also what we are seeing due to daily rates of sophisticated vessels, so many people and ship owner is trying to combine lots of different aspects in a one vessel. For example, we have one fishing vessel who has DP2 capability, because most of the time it will work as fishing vessel, but owners would like to have the idea that some of the times they can use as a tanker or hire to other people. That's why this kind of multi-purpose vessel in offshore, in fishing, will be, we believe that it will increase. And what we have to do for the technology, be part of the technological revolution. As Turkey, we are implementing very good, but we are not a producer. We have to produce something about the technological matters. We have good electrical companies, electrical integrators, accommodation companies, accommodation integrators. But as a base product, we do not have sufficient capacity. We have to be careful on that side. And we are working with Europe, and also our government has new policies about this clean earth fact. That's why as people and as engineers, as shipyards, we have to follow the regulations and also try to follow the regulations as much as possible. And of course, research and development departments are very important, and we have to investigate, we have to arrange budgets for that, and we have to support our universities, definitely. And one of the important things I check, we are always try to catch the trends. And Turkey is a trending place for so many vessels and so many eras. For example, in 2005 to 2009 is a tanker bulk carrier season. Now we are talking about passenger vessels, really offshore projects, and now we are in the era of fishing projects. That's why Turkish shipyards also or market should follow also the trends, what is coming on and what is going on. That will be our future improvements. And I think my slides are finished. Thank you very much for listening to me. Actually, it was a pleasure. And if you have any questions, I can ready to answer together with Mrs. Mehtap.
Okay. I would like to thank Mr. Burak Mursaloğlu for his presentation. Now I am checking there are any question posed to speakers on YouTube. I guess there is no question. So we would like to thank all the speakers again for the valuable presentations and the sessions. See you in next sessions.
Thank you. Have a nice day.
Have a nice day.
Bye. Thank you.